Hello my dear friends, welcome to this next video. In this video we are going to discuss a problem which was asked in GATE 2020 question number 55. It is related to real analysis. So let us look at the statement. The statement says the value of this particular integral, right? Limit of an integral is what? And you have to round off to the 3 decimal places, right? So it's not very hard question. First you have to look at the integral, right? Now and also you have to take limit n going to infinity. That will do at a later stage. First, if you look at this integral, then you may think of integrating by parts, but here look at e raised to power x square, so and x raised to power n. So if you do integration by parts, you see x square's derivative, because of the chain rule, will come in front and you will not be able to get rid of any one of the two functions, right? So that will not work. So what else we can do? We can write the expansion of e raised to power x square. So what I am doing here is I am writing the expansion of e raised to power x square, that is 1 plus x square by 1 factorial plus x square square, which will be x raised to power 4 by 2 factorial, then x square raised to power 3 by 3 factorial, and so on. So this is the expansion of e raised to power x square. Right, now what we are going to do, we have this x raised to power n and this is the expansion of e raised to power x square. So we are going to multiply. Now when you multiply x raised to power n with 1, you will get x raised to power n. When you will get x raised to power n with x square, you will get x raised to power n plus 2 by 1 factorial, then x raised to power n plus 4 by 2 factorial, x raised to power n plus 6 by 3 factorial, and so on. And this n, because it is independent of x, it will come out of the integral sign. Now it is very easy to integrate. X raised to power n integration would be x raised to power n plus 1 by n plus 1. Here it would be x raised to power n plus 3 by n plus 3. Here it will be x raised to power n plus 5 by n plus 5, and then there is a 2 factorial also. And then your integration is from 0 to 1. Right, now you put the limits. When you put 1 everywhere, so you'll get, and this n also I am multiplying, so this will be n upon n plus 1, n upon n plus 3, n upon 2 factorial into n plus 5. Okay, this is 5, and so on, right? So and now what you have to do, you have to do n going to infinity. So what will be the limit? How we can write it? We can write it like this: 1 upon 1 plus 1 by n. You divide with n, numerator and denominator. Here you can write it as n 1 upon 1 plus 3 upon n. Here you can write it as 1 upon 2 factorial into n plus 5 by n, and the next term would be 1 upon 3 factorial into n plus 7 by n, and so on. When n goes to infinity, these terms goes to 0, so you'll get 1 plus 1 plus 1 by 2 factorial plus 1 by 3 factorial, and so on. So what is this? This is the expansion of e, and we know that the value of e to the 3 decimal places is 2 minus 2.113. If you don't remember the value, you can just calculate these terms, right, in a calculator, and you can find out the term by rounding off to 3 decimal places. So this is how we can do it. If you have any doubts, please write in the comment box. Please share this video and subscribe to this channel. Happy learning!